Hello, you're welcome to this lesson. In this video, you are going to solve this question I have on the screen. The question says an alternating sinusoidal current of frequency 60 Hz has a maximum value of 120 amperes. Write down the equation for its instantaneous value. Recording time from the instant the current is 0 and is becoming what? Positive. Find A, the instantaneous value after 1 over 360 seconds, and B, the time taken to reach 96 amperes for the first time. So let's look at how you are going to solve this question. So the first thing you have to do is write down the equation for the instantaneous value. Okay, so the general expression for the instantaneous current of a sinusoidal AC quantity is given as I. Okay, let's write it as I of t. Okay, will be equal to the maximum value. Okay, multiplying sine of 2 pi ft. Okay, this is the general formula. Let me write this again. 2 pi ft. Okay, where f is the frequency. Okay, f is the frequency, and then t is the time. Okay, t is the time, and then I sub n is the amplitude or the peak current. Okay, amplitude or the peak current. Okay, so from this question that we've been given, we know the maximum value, right, which is 120 amperes. Okay, and then we know the frequency, which is 60 hertz. Okay, so the question says that we should write down the equation for its instantaneous value. Okay, so we are going to have the equation for the instantaneous value to be equal to I of t, that will be equal to Im, which is 120. Okay, sine of 2 pi. Okay, ft, and then our f is the frequency, which is what? 60 now, so times 60 multiplying the time t. So you are going to have the instantaneous value to be equal to 120 sine of 2 multiplying 6 to give us 120. So you're going to have sine of 120 pi t. So this will be the equation for the instantaneous value. So now let's go back to the question. It says that A, we should find the instantaneous value after a time of what? 1 over 360 seconds. So let's look at how you are going to do this. Okay, so for this one, we've been given the time to be 1 over 360 seconds. Okay, so we just go back to the equation for the instantaneous value, which is given as I of t. Okay, and then that's equal to 120 sine of 120 pi t, right? Okay, so now you know the value of our t, okay, which is 1 over 360. Okay, so you are going to have this to be I of 1 over 360. Okay, and then this should be equal to 120 sine of 120 pi, okay, multiplying 1 over 360. Okay, so let's simplify this. This is in radians. Okay, we are doing this in radians. Okay, if you don't want to do this in radians and then you want to do it in degrees, then you are going to have this to be 120 sine of 120 pi. The pi now becomes 180, so you are going to have times 180 times 1 over 360. Okay, so this will be for degrees. That's if you want to work it out in degrees. Okay, so let's continue. I'm still continuing with the radians. So you are going to have the instantaneous current, okay, at a time of 1 over 360 seconds to be equal to, let's compute what you have at this side first. Let's compute this first. Okay, so we have the sine of 120 pi multiplying 1 on 360. Okay, so that gave me a value of square root of 3 on 2. So and then we are going to have 120 multiplying the square root of 3 on 2. Let's see what you are going to get. So that gives me a value of 60 root 3. Okay, which in decimals will give us 103.9 amperes. Okay, so that means that the instantaneous current at a time of 1 over 360 seconds will be 103.9 amperes. Okay, so now let's move on to the second part of the question. The second part of the question says that we should find the time taken to reach an instantaneous current of 96 amperes for the first time. Okay, so for this one, we've been given the value of the instantaneous current. So we are going to have I of t to be equal to 96 amperes. Okay, but we don't know the time that it took for us to get this instantaneous current, 96 amperes. So let's find the time. So we're going to equate this to our 120 sine of 120 pi t. Okay, this is what you are going to do. And then our goal here now will be to find t. So let's look at how we are going to do this. So let's find a value of uh, let's find the value of so let's find the value of t. Okay, let's look at how we are going to do this. Okay, so to do this, first of all, I'll divide both sides by 120. Okay, I'll divide both sides by 120. Let's see what you're going to get. So then we're going to have on the right hand side, on the left hand side, sorry, you will have 96 on 120. That gives us a value of what? 4 on 5. So let me write this as sine of 120 pi t. Okay, equals 4 on 5. Okay, I just rewrote it, changed but the sine of 120 pi t to the left hand side, and then the 4 on 5 to the right hand side. So let's simplify this and see what you are going to get. Let me continue from here. Be continued. Okay, so at this point, what you're going to do is that because we want to find t, okay, I'm going to take sine inverse, okay, of both sides. So when I do this, we are going to have 120 pi t, okay, equals the sine inverse of 4 on 5. Okay, this is what you are going to do. So let's see what you are going to get. So you have 120 pi t to be equal to, let's find the sine inverse of 4 on 5. So that gives me a value of 0.927. Okay, so let's make it 0.93. 0.93. Okay, so our t will be equal to 0.93, okay, divided by 120 pi, right? So let's what you're going to get. So you have 0.93. So you have 0.93 divided by 120 multiplying pi. That will give us, let me try this again. Okay, so that will give us a value of 0.0025 seconds. Okay, so that will be the time that when you substitute into the general formula that we got, which is this equation, will give us a current of what? 96 amperes. You might not get 0.0025 exactly, okay, just because of how I rounded the numbers. Okay, so if you get anything closer, it means you are correct. Thank you very much for watching this video. Please make sure you like the video and then subscribe to the channel so that anytime I upload videos, you will be notified. See you in my next video.